Hello and welcome to the Linux Lighthouse, your guide to openSUSE Linux. In today's video, we will dive deep into authentication with PAM, Pluggable Authentication Modules, on openSUSE Linux. Whether you are a system administrator, developer, or Linux enthusiast, mastering PAM is essential for managing authentication and enhancing system security. So, let's get started. What is PAM? PAM, or Pluggable Authentication Modules, is a framework in Linux that provides a modular and flexible way to implement authentication policies. It acts as a middle layer between applications and authentication mechanisms, allowing developers to integrate new methods without altering application code. So, why PAM is important? Before PAM, every application required custom code to support different authentication mechanisms, such as LDAP, Kerberos, or local password files. This approach was time consuming and prone to errors. PAM simplifies this by centralizing authentication logic into reusable modules. So, let's see key concepts in PAM. 1. PAM modules. These are shared libraries that implement specific authentication tasks. For example, PAM Unix.so handles traditional password authentication using /etc/pass wd and /etc/shadow. PAM_env.so sets environment variables during login. PAM U2F adds U2F based two-factor authentication. 2. Services. A service is any application or a daemon that uses PAM for authentication. Examples include login for console login, sshd for remote login via SSH, SU for switching users. Each service has its own PAM configuration file, such as /etc/pam.d/sshd for SSH. Number 3, module stacks. A module stack is a sequence of PAM modules executed in order. For example, a typical login process may involve checking if the system is in maintenance mode, pam_no-login.so, verify user credentials, pam_unix.so, configuring the session environment, pam_env.so. Module arguments. Number 4. These are options passed to modules to customize their behavior. Common arguments include debug enables debugging output, null OK allows empty passwords, and try first pass reuses the password entered earlier in the stack. Why understanding PAM configuration matters. While high-level tools like pam-config simplify PAM management, understanding its configuration files is crucial. This knowledge helps you debug authentication issues, customize behavior for specific services, and enhance security. Keep in mind, misconfiguring PAM can lock you out of your system. Always test changes carefully and keep a backup of the original configuration files. While configuring PAM by hand is rarely a good idea, and most Linux distributions discourage it and provide high-level configuration tools instead, it is still important to understand how its configuration files work. PAM configurations are stored in /etc/pam.d. On openSUSE Tumbleweed, it's in /usr/lib/pam.d. Each file corresponds to a specific service. For example, sshd under /etc/pam.d handles authentication for SSH. /etc/pam.d/login used for console logins. Each line in a PAM configuration file has four components. Declares the purpose of the module. PAM recognizes four types. Auth verifies user identity, for example, through passwords or biometric scans. Account checks if the account is valid, for example, not expired. Password manages password changes. Session configures and manages user sessions, for example, setting environment variables. 2. Control specifies how to handle module results. Required all required modules in the stack must succeed. Failure is reported only after all modules are processed. Requisite if this module fails, the process stops immediately. Sufficient if this module succeeds, the stack terminates successfully, provided no prior required modules have failed. Optional failure or success doesn't affect the overall result unless it is the only module in the stack. 3. Module path points to the PAM module. For example, /lib64 security pam underscore unix.so. If the module is in the default directory, you can omit the path. For module args or arguments, customizes module behavior. For example, auth required pam underscore unix.so null OK, try first path. Let's consider sshd PAM configuration as an example to clarify more the points that we stated before. The first line here, pam-1, it declares the version of this configuration file. This is merely a convention but could be used in the future to check the version. This statement, according to the official manual of openSUSE, pam underscore no login checks if /etc/ no login exists. If it does, no user other than root may log in. For common dash auth, it's refer to one of the configuration files of four modules, which is common dash auth, common dash account, common dash password, and common dash session. These four files hold the default configuration for each module type. Another example, pam underscore login UID. Sets the login UID process attribute for the process that was authenticated. And for an example, option control, the last one, pam underscore MOTD, stands for message of the day, and it will print the message of the day that you configured on your system when a user uh, make a login to the system. Also, it's a good thing when including the configuration files instead of adding each module separately to the respective PAM configuration. You automatically get an updated PAM configuration when an administrator changes the defaults. Let's take an example of one of the configuration files that get included in the PAM configuration files of sshd, which is common-auth. As you can see, the first one, pam underscore env.so, this one loads /etc/ security pam underscore env.conf to set the environment variables as specified in this file. It can be used to set the display variable to the correct value because the pam underscore env module knows about the location from which the login is taking place. Pam underscore kwallet 5.so, because we are using KDE here and it is KDE 5. So if you are on Gnome, this will be pam underscore gnome underscore keyring.so. This checks the user's login and password against the key-wallet keyring or gnome keyring. The last one, pam underscore unix, checks the user's login and password against /etc/passwd and /etc shadow. Another thing to add here, some PAM modules are configurable. The configuration files are located in /etc/security. For an example, pam_env.conf and limits.conf. pam_env.conf can be used to define a standardized environment for users that is set whenever the pam_env module is called. For limits.conf, system limits can be set on a user or group basis in limits.conf, which is read by the pam_limits module. The file allows you to set hard limits, which may not be exceeded, and soft limits, which may be exceeded temporarily. pam-config. pam-config is a powerful tool for managing PAM configuration on openSUSE. pam-config is a tool to help you configure the global PAM configuration files under /etc/pam.d and all the files that started with common has a symbolic link to the actual files with the same name but ends with -pc and several selected application configurations. To list the supported modules on your system, you can use pam-config-list modules, and it's pretty long list. We have to say that use pam-config command to maintain your PAM configuration files, to add new modules or delete other modules or modify options to these modules. Also, when changing global PAM configuration files, no manual tweaking of the PAM setup for individual applications is required. We have to emphasize this. When you go and using PAM config, PAM config is the official tool to deal with the configuration related to PAM files, and it is highly recommended by SUSE and openSUSE that in very limited cases that you may go and do it manually. But let's say you have to go and do it manually, even with PAM config, try to always have another session with root opened, login, like when you are SSH maybe to a remote system or on your own system. Make sure that you have an open session with root account for safety, and in case something didn't work as you expected, you will be able to revert back to the original state of your authentication system using PAM. With PAM, to generate a fresh Unix style PAM, you can use pam-config create, and this command will create the simplest possible setup which you can extend later. When I hit enter and we do ls2 etc pam.d, here these files, common account, common authentication, common password, common session, they are a symbolic link to the same file with the same name but ends with -p. Here these files ends with pam-config-backup. As you can see from the name, that it is a backup created for you when you use pam-config create. To add a configuration or a module to your PAM configuration file, first you need to use pam-config -help. It's a long list of help, and you can check the services of module option, and here all the arguments related to the module options. Okay, how to add the module, because you cannot add them like pam_env.so as a library. So you need to check the correspond arguments for them here. Okay. So for an example, now I created PAM configuration, basic PAM configuration. I can add, like for an example, limits, and it has been added. And let's say I want to add the K wallet, this one. And I will say now why I'm choosing these in particular. And now it is added. Let's say you try to add the module for SSH like that. And it gives you this error, pam_ssh.so. Don't get panic. All you need to do is to go to your package manager zipper and search for that pam_ssh. And let's see if it is there with the same name or maybe with dash. And as we can see, it is in the same name. So all you need to do, go here and do install. And also from SUSE, openSUSE official manuals, that if you're going to install the 164, for some reason, I'm not talking about SSH, but in such a case that your app might run in 32-bit or 64-bit, so install both modules for 64 and 32-bit. Okay. All I need is to just hit enter and I press yes. And if I rerun the command again to add SSH, now it is running. So we can check file and see pm add, and to check the authentication, we will see that it has been added here at last line. And you have SSH PAM configuration added to your configurations. Also, you may query your configuration and to check if there are any wanted options you need to add or everything is okay. So you can write pam-config and query and the name of the module that you added. And you can see that it's authentication and session. And if there is any parameter you added specifically for this module, it should appear here. But it's telling you that this configuration in the authentication file and session file. Let's say you don't want it anymore. So to delete it, just dash delete and the name of the module. And now it is gone. If I do query, nothing there. Again, if you have to edit any PAM configuration file manually, before editing, make sure that you create a backup in this way for the file that you are going to edit. As I said before, always keep an open session or a root terminal to test changes before logging out, because if any mistake happen, you might get logged out from your system. And as we said, that openSUSE Linux provides default configurations in etc pam.d/common and all the files starting with the common word. These include standard modules for authentication, account, password, and session. Again, as we said before, that try to avoid manual configuration unless necessary and use pam-config whenever possible. Manual changes are prone to errors and can be difficult to debug. Congratulations, you now have a comprehensive understanding of PAM on openSUSE Linux, especially Leap, from its modular architecture to practical configurations. PAM is an indispensable tool for managing system authentication. If you found this video helpful, don't forget to like, share, and subscribe to the channel. Leave a comment below with your questions or topics you would like me to cover next. Thank you for watching and see you next time.